In this video, we'll create a full-stack app using React as the front-end and Node.js as the backend with Remult. Remult allows you to write your CRUD code once and reuse it as the model both for the front-end and the backend. We're going to follow the Remult React tutorial, which starts with a very detailed steps of setup, starting with the Create React App template. Now, to skip through those steps, you can click this TLDR shortcut over here, just copy this code and paste it in your console. During the setup phase, we are using Create React App with the standard TypeScript template. We're adding to it Axios and Express and Remult. We create a very basic Express web server, okay, that uses the Remult Express also. And we define a very basic common TS class in the front end that uses Axios and wraps it with Remult. Let's check out the code. Okay, we've opened VS Code, and we see we have a standard solution, standard project built by Create React App, to whom we've added the server, simple Express server with Remult Express, and we've added the common TS with Axios, Remult, and that will use this code to access whatever we need. So to start it, we're going to go and run the dev npm scripts. That's going to run both servers for us, both the API server and the dev React server. Perfect. So once it's done, we've got the standard Create React App here. Let's check out the steps that we're going to go through in this tutorial. We're going to define entities. We're going to do sorting and filtering, CRUD operations, validations, backend method, authentication, and authorization. So our goal is to write a to-do app, and for that we want to start by creating the task entity. So we'll create a folder called shared that will represent code that is shared by both the front end and the backend. And in shared, we're going to create a new task called task TS. Now our task will have ID. It's going to be actually like this, title. It's going to default to blank. And completed, that is going to default to false. So this is the data type of task, and then we'll decorate it with the entity decorator from Remult. The entity decorator from Remult tells Remult that this class is an entity class. It will be used as the model for the front-end code, for the back-end code, for the API endpoint, and even the database. We give it a key, and later we'll give it some options. We'll do that in a second. And then we'll decorate the fields, making the ID a UUID field, and the title a string field, and the completed a Boolean field. By decorating the ID with the UUID decorator, Remult will make sure that a unique UUID is generated for this entity wherever it is being used. So after we've defined our entity, we switch over to the server index and register it in the entities collection. As soon as we do that, we can see in the console that the API server is restarted, and now we have an API endpoint called /API/tasks. So if we go to localhost 30,002/API/tasks, we see an empty array that represents the tasks that we have today. Great. So we defined the entity. Now let's seed it with some data. So the Remult Express method accepts an option object that one of its entries is called init API. The init API is a method that will run once everything is set up and running, and we can write some startup code here. And we get the Remult object for that. So let's start by saying const task repo equals remult.repo of task. When we call the Remult repo method, it returns to us a repository of tasks that we can use to insert data, to query data, to do all the CRUD operations using our task entity. For example, we can write to the console the number of rows in the task entity, which obviously is going to be 0 at this time. Now let's use this to insert some rows. So I'm going to say if the count is 0, Then await Remult, task repo, insert an array of rows, which is gonna be title task A, and let me be lazy and just create a few of those. You can see B, C, D, E, and let's make 2 of them completed. Okay, so what do we have here in our code? First of all, we check to see that there are no rows in the table, and then we insert the rows to the database. As soon as we save this file, the server will restart and insert the rows, and you can see here that a new folder called db was created with the data. Now, of course, Remult can work with almost any database. The default very basic dev implementation, we use a JSON database, but we can determine any database that we want simply by setting the data provider property here, which we can see here has an article that details the optional databases. And we can see that Remult supports many databases, including Postgres, MySQL, MongoDB, SQLite, and pretty much any database that you want to work with. So as soon as we save that, the data was created, and if we revisit our previous URL of API tasks and refresh it, we can see that we are querying and getting the task from the database. Cool. So far we've defined the task entity and used it both to define our data storage and our API. Now let's use it in the front end and see how that helps us there. Let's go to the app TSX and let's look here at the front end. Start by deleting anything we don't need, which is pretty much anything. So we have now an empty page. Let's start by getting these rows. So the first thing we'll define, just like before, is a task repo. It's going to be remult from common .repo task. Okay. Just a reminder, this remult comes from the common TS class, where we defined it as wrapping Axios. So this remult is going to be used in the front end to perform all the calls to the backend. Then we'll define our function fetch tasks. It's going to return task repo.find. Now let's use it in React. We're going to say const task set tasks equal use state of type task array. Cool. Use effect. Great. And we call here fetch tasks dot then set tasks. Okay. So this will call our fetch tasks method, which is a promise, and then we'll set the task with the result that comes back from this call. Let's draw them on our TSX. And we're going to say div key task.id, and we're going to display task.title. Let's see how it works. Great, we've got our tasks. Now let's put in just an input just to display the checkbox. Checked. Task.completed. I'm using an input here just for the sake of nice visibility. And perfect. We were able to fetch the tasks from the code. So we can see here how we can use the same task entity that is defined in shared on the backend and on the front end, using the same definitions and getting consistent code across front end and backend. Now the find method is pretty powerful. By default, obviously it returns all items, but it gets some cool arguments. I can say, for example, limit 2, and it will get only the first rows. I can say page 2, and it will get the second page with the second rows. I can say here order by completed ascending, and that way the completed task will be at the bottom. And I can filter, saying show me completed false or true. And all of these queries are server-side queries. We are making the calls to the backend and only getting the data that we need. So if we open the network tab, we'll be able to see that if I change this to false, okay, we'll get a call where completed is false, and we only got back 3 rows from the backend. So this has a very powerful query language which is typed that reuses your model entity to get data from the server based on the single definition of the task entity class. And a little tip, I can put undefined here to ignore this filter. Great. Next thing we want to do, we want to start handling the update and create functionalities of CRUD. So let's start by creating a handle change method. It will get a task and values. And whenever the user will change something using these inputs, we're going to say, okay, set tasks to task.map. If T is the current task, then, sorry, this was, okay, T is current task, then we're going to have task and values, else T. Let's make some more room here. So again, we have the handle change that gets a task and the values that we want to set to it, and then replaces that entry in the tasks array. Let's use it here. On change. Yeah, let's be organized. Handle change, get the task, and say completed is E target checked. Now let's see that the checkbox works. Perfect. And let's do the same for the title. So I'm going to say input value task.title, and on change E handle change task title E target value. Cool. So now I can make changes here and it will change the data in React. Next, we would like to save these changes to the backend. So we're going to add another method here, const save task equal async okay, and then we say const updated task equal task repo dot save of task. We're asking the repository to save the task. Once it's saved, we're going to get back an updated task from the server with the values as they are currently on the backend, and then we'll replace the array, the task array, with this task. If T is task, then updated task, else T. And we'll call the save button over here. Save task of task. Perfect. Let's check this out. Let's add 1, 2, 3 over here and save. And we can see on the request from the server that the data was not saved. Now, why wasn't it saved? We actually can see that we got an error in the network tab. Let's review that. We got a forbidden error. And that's a good time to say that the task entity controls your API and also allows things to it. When we define the task entity, okay, we just defined it, and by default, all entities are API read-only. They can only be read from the API and not updated. To allow the users to update them, we'll add a second parameter and say allow API CRUD equals true. Now, of course, we have a much more fine-grained control like insert, read, update, all as separate items, but to allow the entire CRUD operations, we said allow API CRUD true. So now let's do that again. Update 1, 2, 3, save, and we were saved. And let's look at our local host and refresh. We can see that the value was saved. And actually, because we are using a JSON dev database for dev, we can actually see it live. We can say save, and we can see that the value has changed here. So update works. Let's add the ability to add a new task. So again, const add task, and we're going to set the tasks with the current value of tasks and a new task. And we'll add a button here, add task, on click, add task. So this will add an empty task, and we can type a value in it, save it, and that value will be saved to the database. So we've done update, we've done save. Let's just do delete for the sake of completeness. Const delete task, await task repo.delete of task, and then set tasks as tasks.filter t is different than task. And let's add a button for the delete, which on click will call delete. On click will call delete task of task. I have too many curly brackets here. Cool. So now we'll delete F, refresh, and F was also deleted from the database. So far we've seen how we can use the task entity to write some code on the backend, like this init API code, define the APIs that we can use, define the database that we use, and also use the same task entity to work in the front end. We use the same definition of task both for the backend and the front end. Now we can take some more things that should happen both in the backend and the front end and put them in the task entity. For example, validations. Let's say that the task title is required and we don't want to add tasks without a title. So usually you will write that validation logic both in the front end and in the backend, but here we can simply do it in the task entity. So we're going to go to the decorator of title and say validate, and I'll start by choosing from a pre-built validators of required. As soon as I do that, when I'll try to save a task that doesn't have the value, let's try to do this and save, it will not be saved to the backend. Okay? And after I refresh it, you can see that it even will not go to the network tab. So let's delete this and save, and you see that the network tab is empty. We are not even sending it to the server. This has become front-end validation, and we can see the error that got thrown here. Okay? And it's interesting to look at the error object because it has a message and a model state that details the different message for every field in our entity. Okay, so we can use that. But what you see here is when I do save, it didn't even go to the backend. Okay, the network tab doesn't include this code. If you were to bypass it and call it via CURL or some other tool, the same validation will also happen on the server. But it's critical to understand that here it will not happen. It will happen both on the front end and on the back end. Now let's go ahead and display this validation error. So we're going to tweak a little bit with this structure, and we're going to say that this is an array that has task and error, which is going to be error info from Remult of task. Okay? And of course it's going to be optional. What we're trying to do here is to leverage the fact that the exception has a model state that we can use and use it to display the error next to the relevant field. So in our save operation, we're going to say try catch and say set tasks to tasks.map. If t is the same task as the one that's being saved, then we're going to return a task with error, else we're going to return t. And in the UI, we're going to add a div statement next to the title saying, or the expense statement saying task.error.model state, this one, .title. Okay, and let's refresh, and let's try and save an empty value. and we get should not be empty without even going to the backend. Okay, and it will also work for new rows. Okay, should not be empty. Cool. So we saw how validation can work in the front end and in the back end. Note that the validation doesn't have to be a built-in validation. We can also create our own custom validations. In this case, let's say that we want to create one, so we're going to type the decorator to the type of our entity, and then we're going to say, okay, bring me a task, and if the task.title.length is less than 3, throw error too short. Okay, let's refresh it, try to save something that is too short, we get too short, and we can save whatever we want. So again, the same validation logic runs both on the front end and the back end and protects our code, and we can make our code more declarative by defining these validations on the entity level. Next, in order to do this, we want to do something a bit more interesting or a bit more complicated, which is going to be setting multiple rows. Let's say that we want to set completed to all of them to true or false. So let's go to RTSX and say here const set all. Okay, and we're going to say for task of await task repo dot find. We want to run on all the tasks on the server and say task repo dot save task and completed. Of course, we're going to await this, and when this is done, we're going to say fetch tasks and then set tasks. Let's add some buttons to do this. And a button to set all completed. Set all true, and the same one for set all uncompleted, set all false, and we can see that it works. Cool. So we've set all the values that we wanted them to set, but you may notice that this runs on the front end. So whenever I say set all completed, it will go ahead and make 5 put statements because I have 5 tasks to update this data. Now this may work well for 5 tasks, but if we have 500 tasks, this can prove to be too long. So what we would like to do is to move this code to the backend. Let me show you how we do that with minimal syntax changes. So here we have our setAll method. Let me copy it. And let's go back to our shared folder and create a new file called tasks controller. I'm going to say export class tasks controller. And we're going to make this a static async setAll function. Okay, we're not going to fetch again on the server. Great. Now, the next thing we're going to do is we're going to decorate the setAll method with the Remult decorator called Backend method. And we're going to say it's allowed for everyone. By decorating it with this decorator, we are telling Remult that whenever this method is called, make a post call to the backend to run it. Don't try to run it in the front end. And this backend method also allows me to accept a second parameter called Remult, which will get injected on the server with the Remult with the correct context. Let's again define a task repo. Okay, and we're going to make sure that we have this Remult. So this is the same code, same find, same save syntax, but now it's going to run on the backend. Now to add it to the backend, we're going to go to the backend code and register it in the controllers array. As soon as we do that, we get another endpoint for set all. So to recap, by decorating this static method with the backend method decorator, we are telling Remult that whenever the set all method is called, make a call to the backend. Don't run it on the front end. So in app.tsx, we can say now await task controller dot set all with completed. Let's see that it works. We're going to clear the network tab and say set all, and you can see how it called the set all and then reload. It didn't make a one call per task. Set all uncompleted. Cool. And we can see here how it's running pretty fast. So this is how we can easily move logic that initially was working in the front end to the back end and vice versa. Another fun fact that we got here is that this is actually typed. So if by any chance I'm going to send it a string as completed, TypeScript will let us know that we are sending the wrong parameter. Okay, because we're using TypeScript here, we can actually get a typed experience when calling backend code, which is also very important. Cool. So let's review our stages. We've done setup, entities, sorting, CRUD, validations, backend methods. Now let's look at authentication and authorization. This is also a cross-application concern that is important both for the backend and the frontend. We'd like to only allow authenticated people to look at tasks. Okay? So let's go to the tasks entity definition, and instead of saying allow API CRUD true, we can say allow API CRUD allow.authenticated. And that means that CRUD operations will only be allowed for authenticated users. Now, as soon as I do that, I'm going to get an error in the front end, okay? Because I'm not allowed to fetch from tasks, which is great. Let's just create an if statement to prevent this error. So I'm going to go to app.tsx, and in the fetch task, I'm going to say if a not task repo dot metadata dot allow API read, return an empty array. And let's make this async so it will be forgive us for that. Cool. So now when we refresh our UI, nothing happens. We don't get the error. And by calling this metadata, okay, we can get metadata for the task entity and see whether or not read is allowed in the front end. So we make the definitions in one place and then reuse it on across our entire front end or back end. Now, to implement authentication, we're going to use standard packages to do that, but of course you can use anything you want to do. Let's just jump here and start doing that. We're going to install JSON Web Token and its friends. And we're going to create a very basic implementation of authentication here, but the idea here is that JSON Web Token will be used to store the user info across the backend and the front end. Okay, so let's the setup complete. We're going to tell React that the package JSON Web Token is not a front-end package, so it shouldn't include it in its bundle. Okay, and then we're going to add an auth controller in our shared code that will do the sign-in. Let's copy this code and put it there. And it's pretty straightforward code. Very, very basic user sign-in. Okay, we're basically getting a username and checking it across a list of users and returning a JWT token for this specific user. Okay, and then we need to make a few adjustments in our code. First of all, register it as a controller. Okay, and as soon as we do that and run our dev environment, we'll be able to see that we have another endpoint, okay, for sign in. And next, we're going to adjust the backend code to use express JWT. Okay, and this code tells Express to decode the JWT token before passing it on to Remult. Okay, So whenever we get a request, it will decode its JWT value and send it as an auth member later to the Remult code. And we're going to have something similar in the front end. Let's go to Common TS. That basically adds some token management here. So we have the Remult like before, okay? And we have a set auth token that stores the token in our session storage and tells Remult who is the current user based on the token. Okay, and then we add an Axios interceptor to include the token in every request that we send to the backend. So this is a very basic JWT implementation that makes sure that it works end to end, but of course you can add any authorization authentication method you may want around it. Simply just make sure to call Remult set user both on the backend and in the front end in the correct context. And now we can add some basic sign-in functionality. So I can just copy it to save time for all of us and review it in a second. So I'm going to go to our code, to our return statement with the div here and say paste. And then I've probably forgot something. Yes, I need to import some stuff. And here I'm going to say load fetch tasks, then set task, because we want after the sign-in to set the tasks. Cool. So what have we added? We have the username, we set username. We've added a sign-in method that will sign in, and after that will fetch the tasks. Okay. A sign-out method that will update it with null and with an empty array. And for the AI, we're saying if not Remult is authenticated, display an input for the username and a sign-in button. Else, say hi and a sign out button. Let's take a look at this. Now we have a sign in button. If we sign in with someone that is invalid, we're going to get an invalid user error. And if we're going to sign in with Steve, okay, that exists in our auth controller user list, we're going to get and see our tasks. And that's how easy it is to work with authenticated users across the code. And the great advantage here is that the setup code only happens once, but in the task class, we have a very declarative definition of who is allowed to see this data. Now, this can be done a lot more fine-grained. We can make this even a role-based, get authorization, not just authentication. So for this example, let's go ahead and say, okay, allow API CRUD, that's one thing, but let's say that allow API insert is only allowed for a user that is authenticated. Allow API update is only for users that have the admin role. Okay, so only admin users can update tasks. And allow API read is for authenticated. And allow API delete is also just for admins. Okay, and of course we can create a lot more complicated rules. The decorators for entity is the place where you want to put anything that is declarative about this entity. Now we can even make it fine-grained for the different columns. I can say that the completed column will only allow update for admin users. Okay? So only admins can change. Actually, let's not do this for the completed. Let's do that. Yeah, let's copy it here. So you can see how we can define fine-grained declarative rules on the entity, and those will be imposed all around. Now, the only thing we need to do to get this to work is actually defined in our auth controller that Jane is an admin. Okay? So now, if we're going to try and update something, we're going to get an error, a 403 error, because put is not allowed. But if we sign out and sign in as Jane, now we will be allowed to update. Okay? And this declarative way of defining things in the task entity works in our benefit by creating consistency and removing duplicity. Cool. So we've completed pretty much everything we wanted to do so far. All that is left is deployment. Now for this demo, we're going to deploy to Heroku because they make it very easy to deploy. Of course, this can be deployed to any framework. Anything that supports Node.js will work here. Let's start by setting up the things we need to set up. So we're going to install compression and helmet. Compression will make sure that our Node.js server will compress all the results, and helmet will make sure that it's as secured as possible. And let's go ahead and work on our server code. We're going to add compression and helmet. And we're going to use helmet and compression. And we're going to also add some code here that will define that this API server will also be used to serve the static files of our code. That way we can use a single web server in Heroku to serve both the front-end code and the back-end code. Of course, this is not mandatory by any way, it's just here to make the full use of Heroku, but you can deploy the front-end and back-end in different servers and just connect between them with whatever you want. But for the sake of simplicity, we use a single server in this demo. Next, we're going to modify the build and start scripts to build not only React, but also the server code, the backend code. So let's go to our package JSON, and change the start to actually start our Node.js server, and the build to build not only React script, but also the server code. Great. Now, before we deploy to Heroku, we're going to add some Heroku specific code. We're going to say install these items, which are PG, Postgres. We're going to use an actual database when we deploy this, not just JSON files. And we're going to use Postgres for that. And we're going to also use a Heroku SSL redirect, which makes sure that whenever a request comes in, it will switch over to HTTPS. Now let's configure this on our backend. So again, in our server index.ts, we're going to import these guys. And we're going to say use SSL redirect. Again, this tells Heroku to replace HTTP with HTTPS. And we're going to define a data provider. So just like I've mentioned earlier, by default, we're using a very basic JSON data provider. But now we're going to use, if we are running in production, we're going to use a Postgres connection based on Heroku. Great. So far for the code. Next, we need to create a Heroku site. Now, I'm not going to talk in details about how this works with Heroku. You need to create an account, sign in, and then this method works for you. It created a site with this nice little name. We're going to configure it with a token. This token is used to sign the JWT, so we're going to use a very secretly generated ID. Okay, this is very important in terms of security to have a completely random token sign key. And then we're going to add an Heroku database. Great, so now we have Postgres defined on our Heroku server. We're going to commit this all to Git and push it to Heroku. And we'll wait for it while it pushes to Heroku. Okay, currently it's pushing to Heroku. Heroku is installing everything and setting it up. And while we wait for it to deploy, I'm going to show you that although this is a very basic demo that just shows one entity, Remult can be used to create full-blown applications. Here is a nice CRM application demo that we've written that uses React and MUI design to create a full-fledged CRM with lots of components and entities and whatever. And it's also stored in Heroku. Feel free to visit it and see how it works for you. And you can use this example to see larger, more meaningful projects and code samples. And we can see here that it loaded. So this is our CRM application. We have contacts. We have a Kanban where we can drag and drop and do all sorts of cool things. You are more than welcome to come and visit the CRM demo repository on GitHub, take a look at it and see some good examples. And we'll keep waiting for Heroku to complete its deployment. Once Heroku is done, we can copy the Heroku apps open command, paste it here, and it will open our app currently stored at Heroku. We're going to input Jane as the user. And as you can see, our website is now deployed in production and works using Postgres database on Heroku. All of this in around 40 minutes. So in these 40 minutes, we were able to create a full-fledged CRUD application for a to-do app using the task entity that supports all CRUD operations, backend method, authorization, authentication, and even deployment. All this in a very short period of time. So hopefully you'll like this and use this. Please star our repo if you like it, and I urge you to also take a look at the CRM example to see larger, more interesting projects. Thank you for watching, and hope to hear from you in our issues or anywhere else we can help with.